Hey guys, what's up? So today we're going to be looking at frequency curves, right? And it says if a large sample is taken from a very large population, so let's say for example China, India, United States, those are pretty large populations, and a frequency polygon is drawn for midpoints which are relatively close to each other consecutively. We can literally draw a curve through the points instead of straight lines. We say that the frequency polygon tends toward a smooth continuous curve called a frequency curve. And the types of frequency curves that we're going to look at the normal curve, the negatively skewed curve, and the positively skewed curve. So here we're looking at a normal distribution example here, guys, and the median, and the mode are actually the same for normal distribution. And you always plot frequency against the variable. So frequency is on the y-axis and variables on the x-axis. And we have this line here, which is considered the central position, and this top here is called the axis of symmetry, right? So pretty simple thing. We're just gonna go through these three types of curves and explain why they're useful in statistics and what they're about, and then we're gonna move on. So the first one we're gonna look at, guys, is the normal curve. Okay. All right, guys. So now we're gonna be looking at the normal curve, and it says in ideal experiments dealing with large samples from a very large population, a symmetrical bell-shaped curve is obtained when the variable is plotted against the corresponding frequency. The bell-shaped curve is known as the normal probability curve and is said to represent a normal distribution. In a normal distribution, the measures of central tendency, the mean, the median, and the mode are the same. Cool. So it usually looks like this, guys. And as you can see here in the diagram, the central position, this central position here represents the mean, the median, and the mode. All three of them are the same. So for example, in the same little sketch diagram I put here, here would be where the mean, the median, and the mode are, and all of them would be the same. This here is the axis of symmetry on the top. You have the frequency on the y-axis, and you have the variable on the x-axis. All right, guys. So it's really that simple. Anytime you draw a graph and this graph looks like a bell shape, right? When you plot in frequency, when you plot in the variable against the frequency, you are going to get a normal distribution. And an example of normal distribution, if you try to find the weight of a set of people in a classroom, you'd more than likely get a normal distribution. If you try to find the height, you'd normally get a normal distribution, or test scores. Okay. All right, so let's look into the next type of curve, which is the negatively skewed curve. Okay, guys? All right, guys, so now we're looking at the negatively skewed curve. And it says when a frequency curve is drawn and the graph obtained is non-symmetrical, meaning not like the bell curve shape, the curve is said to be lopsided or skewed. The diagram below shows a negatively skewed distribution that is skewed to the left, and it is. You notice the left side is a little skewed, meaning there's a little downside here on this left side instead of the right. The right is kind of up higher. So negatively skewed distributions occur rarely in their own right. For example, when most people get high scores on a test. And in a negatively skewed distribution, the measures of central tendency are all different in such a way that the mean is less than the median, which is less than the mode, right? So the mean tends to be pulled away from the mode in the direction of extreme values. So as you can see here from the negatively skewed curve, this diagram here is a negatively skewed curve. The mean is less than the median, which is less than the mode. Down here we should have variable on the x-axis, right? And right here should be lopsided. It really should look like this, guys, in a way. But that looks kind of bell-shaped. Let me draw another one. let's say it should look like this, right? So the left side should be basically like lopsided in a way. Um, and that's the example of the negatively skewed curve. But the most important thing we need to remember is that the mean is less than the median, which is also less than the mode in this negatively skewed curve case. All right, guys? Cool. So now we're going to look at the positively skewed curve. And right, so let's get that done. Okay, guys? All right, guys. So now we're looking at the positively skewed curve, and it says the diagram to the right shows a positively skewed distribution. That is, it is skewed to the right. So if you look here to this right side here, you're gonna notice that the right side is kind of lopsided, mostly to the left. It's pushing the curve over to the left side, right? So the right side is lopsided. And a positively skewed distribution can be obtained for the results of a very difficult test in which only a few students performed well and most of the students performed poorly, right? In a positively skewed distribution, the measures of central tendency are all different in such a way that the mean is greater than the median and the median is greater than the mode. And the mean tends to be pulled away from the mode in the direction of extreme values. So in this case, guys, the most important thing we need to remember is that the mean is greater than the median, which is also greater than the mode. And we can see here from the diagram that the mode is the smallest here based on the variable. The median is the second smallest and the mean is the largest in the diagram here. Cool. All right, so wonderful. So we can definitely move on now. We've looked at all the different graphs that we're going to need for this CXC exam, and we should be okay moving forward. All right, guys, it was a real pleasure spending time with you, and I'll see you in the next lecture. That's it, and I'll see you in the next lecture, and remember to do your best, and God will do the rest.